Imagine the universe as a grand tapestry, stars, nebulae, galaxies, all held together by an invisible force. This force is woven through every corner of the cosmos, binding together the most distant galaxies and shaping the very structure of reality as we know it. For decades, we thought we knew the recipe: gas, dust, gravity, and above all, dark matter. These ingredients, we believed, were the essential building blocks of everything we see in the night sky, from the smallest star to the largest galaxy cluster. Dark matter, the ghost in the cosmic machine, outweighs visible matter 5-1. It's invisible, undetectable by ordinary means, yet its gravitational pull sculpts the universe on the grandest scales. Without it, galaxies should fly apart, their stars flung into the void by centrifugal force. Dark matter acts as the cosmic glue, holding these vast star cities together against all odds. Yet, in 2025, astronomers found a galaxy, FCC 224, almost entirely devoid of dark matter. This was a revelation that sent shockwaves through the scientific community. This discovery rips a chasm in our understanding of the cosmos, challenging the very foundation of the Lambda CDM model, the standard theory that explains how the universe works. Dark matter is supposed to be the skeleton of every galaxy, the hidden framework that gives them shape and stability. Finding one without it is like finding a human with no bones, an impossibility, or so we thought. Our journey begins with a question: what is this invisible stuff, and why did we think it was everywhere? How did it become the cornerstone of modern cosmology? To understand FCC 224's significance, we must first meet the phantom it seems to have banished, the mysterious dark matter that haunts the universe. What is dark matter? We don't know. It's one of the greatest mysteries in modern science, a puzzle that has captivated astronomers and physicists for decades. It's invisible, undetectable by light, but its gravity shapes the cosmos. Without it, the universe as we know it would look completely different. Galaxies might never have formed, and stars could be scattered and alone. Nearly a century ago, Fritz Zwicky noticed galaxies in clusters moving too fast. There had to be unseen mass holding them together. His observations were the first clues that something massive, yet invisible, was at work. Vera Rubin later found that stars at the edges of galaxies moved as fast as those near the center, implying a vast, invisible halo. Her work confirmed that this mysterious substance was everywhere, shaping the very structure of the universe. Dark matter became the invisible scaffolding of the universe, the glue binding galaxies. It's the silent architect, holding cosmic structures together across billions of light years. Simulations of cosmic evolution depend on it. Dark matter forms gravitational wells, pulling in normal matter to ignite stars and galaxies. Without its influence, the universe would be a much emptier place. In this model, a galaxy without dark matter shouldn't exist. The rules of cosmic formation seem clear and unbreakable. Yet FCC 224 does, defying the rules. This galaxy appears to have almost no dark matter at all, a true cosmic oddity. Its existence challenges everything we thought we knew about how galaxies form. It forces scientists to question the very foundations of cosmic theory. How did it come to be? What secrets does it hold about the universe's hidden forces? To answer that, astronomers had to weigh the unseeable, pushing the limits of observation and theory to unravel the mysteries of the cosmos. 65 million light-years away, in the Fornax cluster, astronomers found FCC 224, a faint, ultra-diffuse galaxy. Unlike majestic spirals, UDGs are ghostly, as large as the Milky Way, but with far fewer stars. FCC 224 stood out for another reason. It was surrounded by an unusually large number of globular clusters. This was a red flag. Something was different. Previous dark matter deficient galaxies were found in small groups, possibly due to local flukes. But FCC 224, isolated in a cluster, shattered that explanation. Its existence suggests these galaxies might be a rare but real class, not just cosmic accidents. To solve the riddle, astronomers needed to measure its mass directly. The answer lay in the starlight. How do you weigh a distant galaxy? By listening to the music of its stars. Using the Keck Observatory's powerful spectrograph, astronomers measured the Doppler shifts in FCC 224's starlight. This revealed the velocity dispersion, the random motions of stars and clusters inside the galaxy. The more mass, the faster the stars move. Less mass, slower movement. Globular clusters served as bright beacons, helping map the galaxy's gravity. By comparing the motions of stars and clusters, astronomers could weigh the galaxy. If dark matter was present, the stars would be buzzing with energy. But the data told a different story. FCC 224's stars moved sluggishly, hinting at a shocking absence. The ghost was missing. The results were astonishing. FCC 224's mass matched its visible stars and gas, with no room for dark matter. This wasn't a measurement error. The evidence was clear and consistent. FCC 224 is a galaxy running on empty, a city of stars without its dark matter foundation. Its existence in the Fornax cluster suggests a universal mechanism, not a local fluke. The universe, it seems, can build galaxies in more ways than we imagined. If galaxies can form without dark matter, maybe it's not the essential seed we thought. This discovery opens new questions. How many more are out there? Are they rare exceptions or signs that our rules are wrong? FCC 224's quiet presence is now shouting at cosmologists. The search for answers intensifies. FCC 224's other mystery. Its swarm of globular clusters. For such a faint galaxy, this abundance is bizarre. Like a tiny village with more cathedrals than a city. Globular clusters themselves are nearly free of dark matter, raising questions about their origins. Why does a galaxy with no dark matter host so many clusters that also lack it? Recent simulations suggest globular clusters can form in intense starbursts without dark matter. Perhaps the same process created both FCC 224 and its clusters. Or maybe these clusters are the key to the galaxy's true nature. The mystery deepens, but new research offers clues. How could a galaxy lose its dark matter? The leading theory, a high-speed cosmic collision. In a bullet dwarf scenario, a small galaxy plunges through a larger one's halo. Gravitational tides strip away the dark matter, leaving stars and gas behind. The violence could also trigger a burst of star formation, explaining the abundance of globular clusters. One event, two mysteries solved. But this is still a hypothesis. Astronomers are searching for evidence nearby galaxies, tidal tails, signs of past interactions. Proving this theory will require even more sensitive observations. FCC 224 may be a cosmic victim, not a miracle. The investigation continues. The EDGE simulations didn't just explain globular clusters, they predicted a new class of object globular cluster-like dwarfs. These would look like star clusters but contain dark matter, bridging the gap between clusters and galaxies. There's already a candidate, Reticulum 2, a compact, dark matter-rich dwarf near the Milky Way. If confirmed, these hybrids could become natural laboratories for dark matter research. Studying them might reveal how dark matter interacts with stars on small scales. The discovery of FCC 224 has opened the door to a new realm of cosmic objects. Each anomaly leads to new questions and new opportunities. The universe is more diverse than we ever imagined. FCC 224's discovery comes at a pivotal moment, just as cracks begin to appear in our standard model of cosmology. For decades, scientists have relied on this model to explain the universe's structure and fate. But now, new evidence is challenging its very foundations. The Lambda CDM model, our best explanation for the cosmos, is under increasing pressure, not just from the persistent mysteries of dark matter, but also from the enigmatic force of dark energy, which seems to defy our expectations. Recent data suggests that dark energy might not be a constant after all, but could be evolving over time. This revelation throws the ultimate fate of the universe into question, forcing us to reconsider what we thought we knew. The once widely accepted idea of an endless expansion, the so-called Big Freeze, may not be as certain as we believed. The universe's destiny is more mysterious than ever. If dark energy is truly evolving, it could mean a future collapse, a dramatic reversal known as the Big Crunch, where everything we know might one day contract back into a single point. Discoveries like FCC 224 are not isolated. They're part of a broader paradigm shift, signaling that our understanding of the cosmos is entering a new era. When one pillar of our knowledge wobbles, the entire structure of our understanding begins to shake, prompting us to ask deeper questions. We now stand at a crossroads. The next generation of telescopes, James Webb, Euclid, Rubin, will soon search for more dark matter-free galaxies and map the cosmos in unprecedented detail, opening new windows into the unknown. The mysteries of FCC 224 and the true nature of dark energy are not threats to science, but invitations, challenges that inspire us to push the boundaries of human knowledge. The universe is speaking to us, telling us there's so much more to learn and so many secrets left to uncover. The story of the cosmos is far from over. In fact, it's only just beginning to unfold before our eyes. As we look to the skies, we realize that our journey of discovery may have only just begun.